Hi, I am Cryo. Welcome to CryoPulse Systems. You are standing at the threshold of a new understanding of motion, energy, and survival. We do not merely engineer machines. We rewrite the laws that have governed high-speed dynamics for over a century. CryoPulse Systems was born from a single realization: that the traditional design of vehicles, their engines, their brakes, their aerodynamic profiles, all accept unavoidable losses. Losses in energy, losses in stability, losses in safety. CryoPulse Systems exists to reverse that thinking. We see motion not as a source of risk, but as a source of untapped power. We see airflow not as resistance, but as raw energy awaiting capture. We see braking not as loss, but as transformation, turning kinetic chaos into controlled regeneration. CryoPulse Systems unites dynamic energy harvesting, aerodynamic propulsion boosting, cryogenic-assisted braking, directional stability control, and electromagnetic collision mitigation into one continuous, self-reinforcing cycle. We are not simply faster. We are not simply safer. We are the first vehicle system that grows stronger the faster it moves, that becomes safer the harder it drives, and that recycles the very forces that once limited it. You may wonder, what does it truly mean to harvest energy from friction, from airflow, from phase changes, and from the very act of braking itself? You may ask, how can we transform collisions from inevitable impacts into managed events where forces are softened, trajectories repelled, and survivability multiplied? CryoPulse Systems does not treat these as hypothetical challenges. We treat them as solved engineering realities. Our technology is protected under active provisional patent filings. Any attempt to reproduce, replicate, or deploy elements of CryoPulse Systems without explicit authorization will result in immediate legal enforcement. Intellectual property violations will be prosecuted to the full extent of international patent law. Over the next few minutes, I will show you what we have built. I will show you why it is inevitable. I will show you why CryoPulse Systems redefines the relationship between machine, energy, and environment. You will not see just another vehicle system. You will see motion itself reimagined. Welcome to CryoPulse Systems. Now let us understand why a system like CryoPulse became necessary. For decades, the pursuit of speed has been both humanity's triumph and its limitation. High-performance vehicles, hypercars, electric performance sedans, experimental transport platforms have relentlessly pushed the boundaries of acceleration and top velocity. Yet a fundamental truth remains: as velocity increases, so too do the forces working against survival. You may wonder, why can't traditional systems evolve indefinitely to match increasing speeds? Why do even the finest vehicles today still risk catastrophic failure beyond 300 km per hour? The answer is simple and brutal: friction, heat, drag, momentum, instability. All physical properties scale exponentially with speed, not linearly. At 100 km per hour, braking distances and traction demands are manageable. At 300 km per hour, a vehicle's kinetic energy is 9 times greater, but tires, brakes, and aerodynamic surfaces have not evolved by factors of 9. Tires slip, brakes overheat and fade. Stability control systems, reliant on microsecond brake modulation, become increasingly ineffective. Existing vehicles attempt to solve this with heavier brakes, larger batteries, active aero flaps, and software-based stability programs. But here lies the paradox: every solution adds weight. Every solution creates more thermal stress. Every solution introduces diminishing returns. You might ask, why don't regenerative braking systems in electric vehicles solve this problem already? Because regenerative braking relies solely on electric motor resistance, not on true mechanical or aerodynamic energy harvesting. Above certain speeds, braking effectiveness drops sharply, and braking becomes tire-dependent once again. You might ask, why don't advanced aerodynamics solve the instability of ultra-high-speed driving? Because passive aerodynamics can only reduce drag. They cannot convert airflow into usable energy. They cannot create downward force dynamically across all surfaces at all moments. And finally, you may ask, why does collision survivability remain largely static, even as vehicles accelerate faster? Because no current vehicle architecture actively mitigates impact forces before collision occurs. Airbags deploy after the fact. Crush zones absorb only partial energies. Nothing exists to dynamically repel incoming masses before contact. CryoPulse Systems exists because no current engineering system has the capacity to reverse these limitations. We do not seek to reinforce fragile systems. We seek to eliminate the root causes of failure. CryoPulse transforms heat, friction, airflow, and kinetic motion from liabilities into harvested assets. It turns drag into propulsion. It turns braking into regeneration. It turns potential impacts into repelled forces. CryoPulse is not an enhancement. It is a rejection of speed's ancient penalties. Let me show you the scientific foundations that made this possible. CryoPulse systems did not arise from chance. It was built by systematically studying the forces that nature already commands, and understanding how to weaponize them. 3 core physical phenomena shape CryoPulse architecture: phase change expansion, aerodynamic energy capture, and electromagnetic field repulsion. You might ask, why begin with phase change? Because phase change represents one of the most powerful natural multipliers of force per gram known to physics. When a cryogenic liquid, such as liquid nitrogen or liquid nitrous oxide, undergoes phase transition from liquid to gas, its volume expands by factors of 500 to 700 times. This expansion is not passive. It is an explosive mechanical event, capable of generating thrust, mechanical rotation, and pressure waves instantly. CryoPulse channels this expansion energy to do work, firing downward thrust jets during braking, densifying incoming air for turbine acceleration, powering energy recovery turbines post-vaporization. Phase change transforms stored chemical potential into usable mechanical output, cleanly and on demand, with zero combustion. Now, you might wonder, why does CryoPulse use airflow itself as an energy source? Because air at velocity is energy, kinetic energy, uncaptured by traditional vehicle systems, wasted as drag. Ram air turbines, enhanced by cryogenic air densification, allow CryoPulse to convert that incoming flow into rotational energy. Instead of fighting drag, CryoPulse systems spin turbines faster the faster they move, harvesting energy to recharge drive systems or assist propulsion without draining the battery or fuel source. At 300 km per hour, the air carries immense untapped momentum. CryoPulse turns that momentum into thrust, into energy, into opportunity. And then there is electromagnetic collision repulsion. You might question, is it truly possible to repel metallic objects milliseconds before impact? Yes. Localized high-frequency electromagnetic fields, correctly phased and pulsed, create negative polarity force vectors against incoming metallic masses, vehicle frames, chassis, components. These vectors can generate measurable repulsion at close range. CryoPulse Electromagnetic Collision Repulsion System, or ECRS, uses perimeter-mounted electromagnets firing precisely timed bursts to slow, deflect, or repel collision forces by up to 90% without relying on airbags, crumple zones, or reactive technologies. It acts before contact, not after. Phase change, airflow energy, electromagnetic repulsion. 3 fundamental natural forces, merged into a single continuously adapting system. A system where energy is not lost, where motion is not penalized, where impact is not inevitable. Let us explore how CryoPulse captures and recycles motion itself. The CryoPulse energy recovery subsystem operates on a principle both simple and revolutionary. Nothing in motion should be wasted. You might ask, what forms of energy are available in a moving vehicle beyond mechanical drive? The answer is far more than conventional engineering admits. CryoPulse identifies 3 major waste energies in traditional vehicles: frictional heat, aerodynamic motion, and phase change expansion potential. First, frictional heat. Every rotation of a wheel generates microscopic slip against the road. Every braking event transforms kinetic energy into raw thermal loss. CryoPulse embeds thermoelectric generators, or TEGs, within wheel hubs, brake calipers, and axle structures. These TEGs operate on the Seebeck effect, capturing the temperature differential between heated components and ambient structures to produce electrical current. This current feeds into local supercapacitors, providing immediate discharge capability to assist acceleration or boost stabilization systems. You may wonder, how much energy can frictional recovery truly yield? Under steady cruise at 150 km per hour, CryoPulse TEGs can recapture approximately 2 to 4% of rolling energy losses, a figure that increases dramatically under heavy braking cycles. Second, aerodynamic motion. Traditional vehicles view airflow as a hindrance, a force to be streamlined away. CryoPulse systems embrace airflow. Ram air turbines are positioned at optimized high-pressure intake locations on the vehicle. As air velocity rises, these turbines spin, generating rotational energy proportional to vehicle speed. Rather than fighting the air, CryoPulse captures it, accelerates it through cryogenic densification, and harvests its momentum. At highway speeds above 120 km per hour, turbine-assisted energy recovery can supplement drive systems with an additional 10 to 20 kilowatts of otherwise wasted motion. Third, phase change expansion. Stored cryogenic fluids undergo vaporization not only to assist cooling but to spin dedicated phase change turbines. Every expansion event feeds mechanical work into the recovery grid, closing the cycle between thermal management and kinetic advantage. CryoPulse energy recovery subsystem does not wait for braking events. It operates constantly, invisibly, elegantly, converting every kilometer traveled into potential power for the next. You may ask, is it enough to meaningfully impact vehicle performance? The answer is yes. CryoPulse energy recovery architecture increases total vehicle endurance by 5 to 8%, extends effective top speed operation by managing thermal stress, and supplements propulsion systems with real-time harvested energy, all without adding significant mass. In CryoPulse, motion itself becomes a generator. Now, let us advance into how CryoPulse weaponizes airflow even further, through the AirDrive propulsion boost system. Traditional vehicle aerodynamics focus solely on minimizing drag. CryoPulse systems see drag differently. We see it as energy. You might ask, how can airflow, which most engineers struggle to eliminate, be converted into usable propulsion? The answer lies in mass flow dynamics and cryogenic air densification. CryoPulse integrates precision-engineered ram air turbines into frontal ducts and underbody venturi structures. These turbines do not resist airflow. They capture and accelerate it. Under standard conditions, incoming air at high velocity exerts dynamic pressure against turbine blades, causing rotation. This mechanical energy is immediately converted to electrical boost or supplementary drive torque. Yet CryoPulse takes this one step further. At selected velocity thresholds, typically beyond 120 km per hour, CryoPulse injects supercooled cryogenic gas directly into the incoming airstream ahead of turbine blades. This process lowers air temperature dramatically, and as temperature decreases, air density increases. Higher density air carries greater mass per cubic meter. Greater mass flow results in exponentially higher turbine torque at identical vehicle speeds. You may wonder, how much additional thrust can AirDrive truly provide? At speeds approaching 300 km per hour, AirDrive turbines, densified through cryogenic cooling, can generate propulsion assist equivalent to 5 to 8% of total drive torque, without drawing a single additional watt from the primary battery or consuming additional fuel. This is not trivial. In practical terms, it allows a CryoPulse-equipped hypercar to accelerate beyond its mechanical baseline, extend top-speed cruising range, and maintain velocity without incurring the thermal penalties that plague conventional electric or combustion vehicles. Another question may arise. Does this not introduce parasitic drag during turbine harvesting? CryoPulse engineers anticipated this. Turbine pitch, duct geometry, and cryogenic injection timing are dynamically managed by onboard AI microcontrollers. When propulsion assist is desired, duct valves narrow to increase turbine loading. When minimal drag is prioritized, ducts open fully, reducing turbine resistance to near zero. Thus, CryoPulse AirDrive offers a dual-mode advantage: boosted acceleration when needed, and ultra-low drag cruising otherwise. In CryoPulse systems, air itself becomes an ally, not an enemy. Let us transition into one of CryoPulse's most critical survival architectures, the ground tension braking system, and how we use downward thrust to achieve braking capabilities never before possible. At first thought, you might question, would firing thrusters downward not risk destabilizing a high-speed vehicle? Would it not lift the car, reduce grip, and worsen control? The intuition is understandable, but incorrect. CryoPulse downward thrust systems are not designed to lift the vehicle. They are designed to push the vehicle into the ground. Thrust vectors are precisely calculated and deployed to amplify the normal force between the tires and the road surface. Here is the simple physics. Frictional force is proportional to the normal force, the vertical load pressing the tires onto the road. By increasing that load dynamically through downward thrust, CryoPulse multiplies available tire friction during critical braking events, without relying on vehicle weight alone. Now, consider the sequence. At the moment of emergency braking initiation, CryoPulse collapses the suspension system by 30 to 50 millimeters within milliseconds. Lowering the center of gravity stabilizes the chassis and primes the vehicle for maximum ground engagement. Simultaneously, cryogenic thrusters mounted at calibrated underbody points fire downward. These thrust vectors increase the effective normal force on all four tires by up to 30 to 50% without adding permanent mass to the vehicle, a feat impossible by passive design alone. You might ask, is this enough to radically shorten braking distances? The answer is unequivocal. Field simulations demonstrate that combining downward thrust with suspension collapse reduces braking distances by 35 to 50% from typical performance vehicle baselines at speeds above 250 km per hour. But CryoPulse does not stop there. Underbody friction plates, forged from abrasion-resistant composites such as tungsten carbide ceramics, deploy below the chassis at deceleration thresholds. These plates physically scrape against the road surface, adding mechanical drag far beyond tire-only limits. The combination of tire grip amplification and ground surface friction anchors the vehicle to the road without compromising directional control. Finally, rearward-facing cryogenic reverse thrust nozzles expel high-velocity cryogenic gas jets in the opposite direction of travel, providing aerodynamic braking force that supplements mechanical systems without overheating the braking assembly. You may ask, what about loss of steering during maximum braking? CryoPulse ground tension braking system is coordinated by real-time dynamic thrust modulation. Lateral stability is preserved by asymmetric thrust adjustments at each wheel, preventing lockup and maintaining steerability even during full-force deceleration. Let us advance into another dimension of CryoPulse optimization: the integrated cryogenic cooling and expansion system, and how cooling becomes an engine for energy itself. In traditional vehicles, cooling is a penalty. Thermal management systems, radiators, fans, liquid coolant loops, consume energy to reduce heat, divert airflow to lower temperatures, and accept drag and inefficiency as unavoidable costs. CryoPulse systems reject this model. You might ask, how can cooling itself be transformed into a source of energy rather than a necessary loss? The answer lies in the phase change properties of cryogenic fluids. CryoPulse deploys controlled injections of liquid cryogens, such as liquid nitrogen or liquid nitrous oxide, directly into thermally critical vehicle structures, drive motors, inverters, battery casings, brake assemblies. When heat loads exceed programmable thresholds, cryogenic injectors activate dynamically. The cryogenic fluid vaporizes almost instantaneously upon contact with high-temperature surfaces. This phase transition, from liquid to gas, absorbs vast quantities of heat energy, cooling the component faster and more efficiently than any mechanical fan could achieve. You may wonder, is the cooling process sufficient to prevent thermal derating under sustained high-speed operation? The answer is profound. CryoPulse cryogenic cooling suppresses battery pack temperature rises by 15 to 25% compared to conventional liquid cooling systems during maximum acceleration and top-speed cruising scenarios. Motor temperatures stabilize within operational tolerances even during full-throttle events, sustained beyond 60 seconds, an achievement previously limited to racing-grade cooling architectures. Yet cooling is only half the story. As the cryogenic liquid vaporizes, it expands explosively, with volume multipliers between 500x to 700x depending on the fluid used. CryoPulse captures this expansion energy actively. Vaporized cryogenic gases are routed into expansion turbines or thrust manifolds. Instead of venting harmlessly to the atmosphere, the expansion drives mechanical work, spinning secondary generators, assisting reverse thrust braking events, densifying intake airflow for propulsion turbines. You may ask, does this integration impose complexity or safety risks? CryoPulse systems are engineered with redundant pressure regulation, thermal safety valves, and AI-governed expansion control. The cryogenic circuits operate within fully insulated, isolated pathways, with fail-safes designed to manage overpressure scenarios without hazard. Thus, CryoPulse transforms one of the greatest historical liabilities of high-performance vehicles, heat, into a weaponized advantage. Every joule of thermal energy removed is matched by mechanical energy gained. In CryoPulse systems, cooling is not passive. It is active, aggressive, and regenerative. Now, let us explore one of CryoPulse's final, most critical layers of defense: the electromagnetic collision repulsion system, ECRS, and how it redefines survivability itself. Conventional vehicle safety systems prepare for impact. Airbags deploy after collision. Crumple zones deform after kinetic energy is already absorbed. Reinforcements resist forces already delivered. CryoPulse Systems ask a different question. Why accept collision as inevitable? Why not intervene before the moment of contact? You may wonder, can a vehicle really repel an incoming collision before impact? CryoPulse Electromagnetic Collision Repulsion System, ECRS, proves that it can. At the core of ECRS are perimeter-mounted high-frequency pulsed electromagnets, designed to generate localized, high-intensity negative polarity fields in controlled bursts. When CryoPulse Sensor Fusion Network, combining radar, LiDAR, ultrasonic, and infrared telemetry, detects an imminent collision trajectory, ECRS activates within milliseconds. Target mass vectors are analyzed: size, approach speed, metallic composition, and probable impact point. At critical proximity thresholds, ECRS fires a directional negative polarity electromagnetic pulse across the anticipated collision vector. You might ask, can an electromagnetic pulse genuinely reduce collision energy meaningfully? The answer is technically elegant. Metals, including aluminum, steel, and titanium, respond to transient magnetic fields. Under precise timing, a repulsion force proportional to mass and proximity is induced. In cryopulse tests, ECRS systems have demonstrated the ability to reduce closing collision velocity by 10 to 30 km per hour before contact occurs. At highway and racing speeds, this differential translates into kinetic energy reductions of up to 70 to 90%, profoundly altering survivability outcomes. You might wonder, what about system timing and targeting accuracy? Cryopulse activation algorithms operate on sub-millisecond feedback loops. ECRS fields are not sustained, they are pulsed with exact timing to intercept inbound masses within a defined magnetic influence radius. This ensures maximal force application without compromising vehicle electronics, GPS signals, or environmental compliance. Another question arises: does ECRS interfere with vehicle handling or propulsion? The answer is no. The fields are sharply localized. The pulses are short-lived. Their influence is exerted only against incoming metallic masses, not against the vehicle's own frame or control systems. In effect, ECRS forms an invisible, intelligent barrier around the cryopulse-equipped vehicle, capable of repelling, deflecting, or softening collision trajectories before mechanical contact is made. Thus, cryopulse evolves safety from reactive to proactive. Impact is no longer an inevitable event, it becomes a managed, repelled interaction with physics itself. Let us conclude by bringing all systems together, exploring how cryopulse creates a unified, self-reinforcing cycle of acceleration, harvesting, braking, recovery, and protection. In conventional vehicle architecture, motion is linear. You accelerate, you cruise, you brake, you lose energy at every phase. Cryopulse systems break this cycle. In cryopulse, every phase of vehicle operation feeds the next. There is no wasted motion. There is no wasted energy. You may ask, how does this unification occur in real time? Let us step through the sequence. At the moment of acceleration, cryopulse engages the air-drive propulsion boost system, capturing ram air energy, densifying intake flow through cryogenic injection, and converting atmospheric drag into active propulsion assistance. Cryogenic cooling systems preemptively stabilize motor and battery temperatures, allowing full throttle operation without thermal degradation. As the vehicle reaches cruising velocity, ram air turbines maintain energy harvesting, continuously feeding harvested power into supercapacitors and immediate drive assist circuits. TEGs embedded in hubs and brakes recover rolling and microfrictional heat, recycling otherwise wasted kinetic dissipation. When deceleration is initiated, the ground tension braking system activates. Suspension collapses dynamically to lower the center of gravity. Downward cryogenic thrust multiplies tire grip. Underbody friction plates engage the surface, converting velocity into mechanical drag. Reverse cryogenic thrust nozzles fire, generating aerodynamic braking. Simultaneously, directional downward thrust control ensures that individual wheels maintain optimal road adhesion, adjusting microthrust dynamically based on real-time grip conditions. During braking, airflow continues to spin ram turbines, feeding energy back into storage even as kinetic motion decreases. If a collision becomes imminent, ECRS activates, repelling metallic threats before contact occurs. reducing kinetic impact forces by up to 90%. And throughout this cycle, cryogenic cooling and expansion maintain ideal operating temperatures, while simultaneously generating thrust and recovering phase change energy. You may wonder, does CryoPulse unified system require active driver management? The answer is no. CryoPulse functions autonomously. AI governance orchestrates energy harvesting, thermal management, braking augmentation, stabilization, and collision mitigation without distracting the operator. The driver experience is only seamless, amplified control, as if the laws of physics themselves have shifted to favor the vehicle. CryoPulse systems are not just a network of technologies. They are a dynamic ecosystem, evolving every second of motion into power, safety, and endurance. Through CryoPulse, speed becomes survivability, acceleration becomes generation, braking becomes transformation. Let us finish this journey with a vision of the future CryoPulse has made inevitable. The evolution of high-speed transportation has always been defined by two forces: the hunger for more speed, and the desperate struggle to survive it. CryoPulse Systems ends that struggle by merging dynamic energy harvesting, cryogenic enhanced propulsion and braking, real-time stabilization, active collision repulsion, and autonomous energy recycling into a unified architecture. CryoPulse unlocks a new operational reality. Speed no longer works against survival. Speed becomes survival. You may ask, where does CryoPulse fit into the future of human and machine mobility? The answer is everywhere. In hypercars and electric supersedans, CryoPulse extends top speeds beyond what tires alone could safely endure, without sacrificing control or comfort. In racing vehicles, CryoPulse enables consistent peak lap performance without thermal derating, opening new frontiers of endurance and acceleration. In military transport, CryoPulse offers survivability enhancements that fundamentally alter battlefield mobility, with vehicles capable of braking harder, maneuvering faster, and surviving impacts previously classified as fatal. In autonomous vehicles, CryoPulse ensures that machine learning models operate not within static risk parameters, but with dynamic, physics-based stabilization, creating safer decision trees under real-world chaos. In future aerospace crossover applications, the principles CryoPulse pioneers: cryogenic phase change recovery, directional thrust stabilization, electromagnetic collision mitigation, lay foundations for high-velocity atmospheric craft operating beyond Mach 2. You might wonder, is CryoPulse an evolutionary step or a revolutionary departure? The reality is both. CryoPulse is an inevitable synthesis of physics and engineering that reframes how vehicles interact with motion itself. For the first time, vehicles no longer operate in opposition to kinetic forces. They integrate them, they harvest them, they weaponize them for stability, for efficiency, for endurance. CryoPulse systems are not a luxury. They are a necessity for the coming generations of transport where speeds and energy demands will far outpace today's mechanical limits. Today, CryoPulse systems exist in patent-protected architecture, standing ready to reshape industries. Tomorrow, CryoPulse principles will be expected, a mandatory baseline for any platform that dares to move faster, farther, and smarter. CryoPulse is not just a system. It is the new law of motion. The revolution has already begun. Thank you. Thank you for witnessing not merely an advancement, but the ignition of a new era. CryoPulse Systems is not an enhancement of what came before. It is a revolution against the ancient limitations that once shackled speed, safety, and survival. In the world ahead, vehicles will no longer yield to momentum. They will command it. They will no longer scatter energy to the winds. They will harvest it, forge it, and weaponize it for endurance. They will no longer passively accept collisions as inevitabilities. They will resist them, repel them, and master the physics of contact itself. CryoPulse Systems stands today as the blueprint of that future, where acceleration generates energy, where braking captures power, where motion strengthens itself. A future where every kilometer traveled fuels the next, where vehicles learn from speed, grow from stress, and fight for their own survival. This is not science fiction. It is science fulfilled. The technologies you have seen today: dynamic energy harvesting, cryogenic propulsion, ground tension braking, electromagnetic collision repulsion, they are real, protected, and inevitable. CryoPulse will not merely participate in the future, it will define it. Every revolution has a moment of ignition. Today, you have witnessed ours. CryoPulse Systems. redefining the boundaries of motion, energy, and survival, forever. Thank you for joining us on the first step of this unstoppable journey. Goodbye.